Assalamualaikum and hello. I'm going to continue how to do the explanation or describing the solubility of carboxylic acid based on example 10. So we have case 1 here. You have to compare the solubility of butanoic acid and methanoic acid in water. So if you see this kind of question, you got two different carboxylic acids here. And what you have to do, the first thing first, if you can see the structure of it, it's much more easier for you. So draw the structure first and don't forget to label. So I'm going to draw the structure for butanoic acid with 4 carbon atoms. So this is my butanoic acid. So I'm going to label this one as A. And next one, I have methanoic acid, 1 carbon atom, so it will attach directly to H, double bond O, single bond OH. So this one I'm going to label it as B. So if you see here how you want to explain, I'm going to see the number of carboxyl group in these compounds. If you see here, both of them got 1 carboxyl group. So we cannot compare based on number of carboxyl group. So now the second factor, which is the size of molecule, can be used in this explanation. If you see from structure A, you have 4 carbon atoms. So this one, 4 carbon, and structure B, you have 1 carbon atom. So they got different molecular weight from one another. So you can explain right now based on this factor. Choose your subject. I'm going to choose A. Then the first point, I'm going to write it down as A has larger molecular weight than B. So this is the first point. So the second point, what can this larger molecular weight of A can do? It contributes to larger hydrophobic area due to the larger size of alkyl group. So that is going to be my second point. So this is my second point. The one that you have to emphasize here, you have to put larger alkyl group and larger hydrophobic area for A. Depends on your subject. If you just say larger hydrophobic area without mentioning about the size of alkyl group, sometimes you will not get the full mark because this statement for the second point comes together, alkyl group and hydrophobic area. So last point, you have to tell which one has the lower solubility in water. So of course, this one in this case is A. So my third point, I'm going to write it down as A has lower solubility in water than B. So if you got all these 3 points correctly, you will get 3 marks together. So this is how you want to get the full mark for case 1. Now let's continue with case 2. If you see here, I want to compare the solubility in water based on these 3 different structures. So I'm going to label them first. Let's label the first structure as X, this one as Y, and this one as Z. And the next one, I'm going to see how many carboxyl group they have in each structure. So let's focus with structure X. I got 1 carboxyl group. For structure Y, I got 2 carboxyl group. So this one and that one. And structure Z, I got 1 carboxyl group. So if you see here, you can already detect which one is the highest solubility because which will be structure Y. So this one has the highest solubility. So I'm going to put the notes a bit. And the next one, we are going to compare between X and Z. Which one will be the highest solubility? You cannot compare based on their number of carboxyl group because both of them got 1 carboxyl group. So what we will compare here is their molecular weight. So what we will see based on molecular weight is their number of carbon atoms. So for structure X, I have 2 carbon atoms. while for structure Z, I have 4 carbon atoms. So as you see here, X has lower molecular weight that contribute to smaller size of alkyl group, hence smaller hydrophobic area. So it means that X has higher solubility compared to Z. So this one will be the second highest, and Z will be the lowest solubility compared to the other two. So how I'm going to do my arrangement? I'm going to do in decreasing order. So based on decreasing order, we will start with the highest solubility first. So I got Y greater than X greater than Z. So this is my arrangement, and based on this arrangement, I'm going to explain in 2 paragraphs. The first paragraph is about between Y and X. So let's continue with the first point. If you see here, we are going to compare based on their number of carboxyl groups. So I'm going to choose my subject is Y. So the first point is Y has more carboxyl groups than X. The next one, what can it affect from here? So for the second point, you can continue that Y can form more hydrogen bonding with water molecule than X. So what you have to emphasize in these 2 statements is more here. And last point, don't forget to write it down. Y has higher solubility in water than X. So settle for the first paragraph. I'm going to continue with the second paragraph, the comparison between X and Z. So I'm going to choose X as my subject. So between X and Z, we are going to compare based on their molecular weight. So I'm going to choose X as my subject. For the first point, X has smaller molecular weight than Z. After that, you have to talk about the size of alkyl group that contributes to hydrophobic area. So my subject still X. X contains smaller alkyl group than X, which contributes to smaller hydrophobic area. So this is the second point. And last point, talk about the solubility in water. So my subject X has higher solubility in water than Z. So this is how you want to explain about examples of question based on case 2 with 3 different structures of carboxylic acid. So I hope all of you understand now, based on these 2 examples, case 1 and case 2, how to explain and describe the solubility of carboxylic acid in water. For the next video, we are going to continue with the next case. I'll see you in the next one. Thanks for watching. Bye.